Continuing this week's notes on formulas, here are the notes for slide 4. Slide 3, we discovered the distance formula. On slide 4, we're going to apply it a little bit to a few problems. So that distance formula equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We're going to be finding distance between 2 points. So in problem number 1, we have one point that is 1, 7, and then the other point B, which is 4, 6. So that means that we have an x1, a y1, x2, y2. So the distance between these 2 points is going to equal the square root of 4 minus 1 squared plus 6 minus 7 squared. 4 minus 1 is 3, and 6 minus 7 is -1. 3 squared is 9, and -1 squared is +1. So we have the square root of 10, and that is the distance between the 2 points. We can put an approximation in if you would like, or you can leave it in radical form. We'll do the same thing with number 2, find the distance between the 2 points, G, which is -1, -5, and H, which is 3, -8. Now, just like with slope, we can swap these around, so we can call this one x2, y2, and then this one x1, y1. The difference with distance formula is we actually want our ordered pairs to be split up, but stay in the same position. I'll show you what that means. So it is x2, -1, minus x1 squared plus y2 minus y1 squared. So what I meant by having our ordered pairs split up is that we have -1, -5. -1 and -5 are split up, but they both come first in the equation. 3 and -8 are split up, but they both come second in the formula. And now we can follow our order of operations to solve. So we have the square root of -1 minus 3 would be -4 squared plus -5 minus -8, that's like -5 plus 8, so that would be a +3 squared. -4 squared is 16, and 3 squared is 9. 16 plus 9 is 25, so our answer is the square root of 25, and the distance between those 2 points is 5, because the square root of 25 is 5.